To graph the secant function, we will look at the reciprocal relationship between secant and cosine. So secant of x is equal to 1 over cosine of x, so we're going to use that reciprocal relationship to graph secant. So here I have the graph of cosine, and for cosine references I will use the red marker. And the first thing I want to do is I want to look at where cosine is 0. So right here, cosine of pi over 2 is 0. Cosine of 3 pi over 2 is also 0. So at those 2 points, the secant of pi over 2 would be the reciprocal of that output, so that would be 1 over 0, which is undefined. So anywhere that cosine is 0, secant will be undefined. So we will have a vertical asymptote for secant at an x value of pi over 2. And then we will also have a asymptote for secant at x equals 3 pi over 2. So it turns out that at odd multiples of pi over 2, secant will be undefined, and those where the asymptotes will be. To see why, let's remind ourselves of the unit circle. So remember that the cosine values on the unit circle come from those points. So we have 0, 1, and negative 1, 0. So cosine is 0 at pi over 2, and then also 3 pi over 2. So we see those 2 points are kind of evidenced once again on the unit circle. So everywhere that cosine is 0, which happens to be the 2 places that are on the y-axis here, where x is 0 at both of those places, secant will be undefined. So secant will be undefined everywhere that cosine is 0, and those are the 2 spots right there on the y-axis. So every time we hit one of those points, secant will be undefined. So that would be 1 pi over 2, and then 3 pi over 2, and then it turns out that as we go around and we start counting off pi over 2's, 5 pi over 2, and then 7 pi over 2, and then 9 pi over 2. It turns out that as we keep counting around, counting those little radian values as we go around, that we stop there at odd multiples of pi over 2. So at all odd multiples of pi over 2, so when we say odd multiples we mean 5 times pi over 2, 9 times pi over 2, 3 times pi over 2, 7, all of those are odd numbers times pi over 2, secant will be undefined. Now let's look at the shared values. Everywhere that cosine is 1, which is here and here, as 0 and 2 pi, secant will also be 1. Remember, 1 is the reciprocal of 1. So we will have these shared values here. Also, where cosine is minus 1, the reciprocal of minus 1 is also minus 1. So we have these 3 shared points at the extreme values. So at the maximum values and at the minimum values, secant and cosine will share those 3 points. Also, we know that at pi over 3, cosine of pi over 3 is 1/2. So secant of pi over 3 would be 2. So when we start looking at those points in between, secant of pi over 3 would be the reciprocal of that, that would be 2. So we start to jump up to values above that y equals 1 line. So our graph looks something like that. So it goes in the opposite direction from that cosine curve, goes away from it above that line y equals 1. So here as well, we have that shared value at minus 1, and the graph will go down in the opposite direction of the sine curve and go down from there as well. So we end up with these U-shaped graphs that point away. They have the shared values at the maximum values and the minimum values, and the graph then has a U-shaped graph that goes away from the original sine and cosine graphs. So here as well, we know that at 5 pi over 3, cosine is 1/2. So at 5 pi over 3, secant would be 2. So we end up getting a graph that goes away from cosine, these little U-shaped segments, And the graph is either above, the graph for secant is either above that line y equals 1 or is completely below a y value of minus 1. So let's look at the quadrants once again. For the quadrants, when we look at cosine, cosine is positive in quadrant 1, so is secant. Cosine is negative in quadrant 2, and so is its reciprocal secant. In quadrant 3, cosine is negative, so is cosecant. And in quadrant 4, we know that cosine is positive, and then notice that so is its reciprocal cosecant. So the graph of the secant function has a period of 2 pi, just like cosine. The range, so here we have a value of 1, and the graph is completely above, so it has the point at 1, and then it goes up from there. And it also has a point at minus 1, and then the graph goes down from there. So the range is from negative infinity to negative 1, and then again jumps up and skips between negative 1 and 1, and then goes from 1 to infinity. And that's a familiar range. We've talked about that before. The domain, what's not allowed to go into the secant function? Well, anywhere that cosine is negative, secant is undefined. So our x values that are not allowed to go in look like this. They look like odd multiples of pi. And this 2n plus 1 is just a fancy way of saying odd. So if I put an integer in place of n, so any number in place of n, multiply it by 2 and add 1, I will always get out an odd number. So this is just a fancy way of saying some odd number times pi over 2. So secant is defined for every x value except for odd multiples of pi over 2. So anywhere on those 2 points, basically, and any coterminal angles that lay on those 2 points on the y-axis. We look at our unit circle. Okay. So the vertical asymptotes occur at all of the x values that are going to give us undefined values. So you notice this is going to be very, very similar here to the x values that we're tossing out from the domain. So it's not defined at those values, so we have asymptotes at those values. So the domain and the vertical asymptotes have a close relationship. So the asymptotes will occur at odd multiples of pi over 2. Since cosine is even and secant is developed from cosine, secant is also an even function. So a negative angle in, if I was to look at that graph, it's going to be exactly the same as the graph of just secant with a positive angle in. One little note that I want to make about both of the cosecant and secant graphs is that they do not have an amplitude. Keep in mind that while we do use sine and cosine as guides, the graphs themselves of secant and cosecant do not have an amplitude. And this is because amplitude, remember, is defined as when we look at the middle of the graph, we want to know when we go to the middle to the top of the graph and from the middle to the bottom of the graph, we want to know what that distance is from the middle to the top and from the middle to the bottom. But notice that secant and cosecant, neither one of them, they have no maximum and no minimum values. In other words, they don't have a top and they don't have a bottom. The graphs actually go upward forever. We have these little arrows that would indicate that. So there is no maximum or minimum value to say we go from the middle to the top, middle to the bottom. There is no maximum or minimum values. There is no top and there is no bottom. So I just wanted to make a little note of that before we go on. And lastly, I would like for us to look at a quick animation for secant and what it looks like. So first we would graph cosine, the reciprocal function. So here's cosine, and notice that everywhere that cosine is on the x-axis there, that's where cosine is 0. Notice that's odd multiples of pi over 2. So negative 3 times pi over 2, negative 1 times pi over 2, 1 times pi over 2, 3 times pi over 2. And those where the asymptotes are going to go. So everywhere we have a point at the middle of cosine, that's where secant will be undefined, and that's where the asymptotes will go. And then if we look at the actual graph here, we can see that reciprocal relationship that occurs with those U-shaped graphs in between those asymptotes.